Hi everyone, welcome to Weeklywed from Business School of AI. Weeklywed is our happy place to learn, share, discuss, and explore. Weeklywed occurs every Wednesday at 9 a.m. Pacific time. I'm your host, Yashaswini Vishwanath, and you can call me Yash. So I'm logging from Bangalore, India, and we would like to get to know where you're all coming from. We would like to get to know you better. Please type away your name and your location so that we can connect with you. I am an AI researcher in artificial intelligence, focusing on responsible AI. I have been doing this research work for quite some time, and there have been publications in this area. So this area is very close to my heart, responsible AI, because we see AI systems all around us, and there is a need for them to be responsible. So this is Weekly Wed. It's an international speaker series on AI, AV, and IoT. We have speakers from all over the world joining us, giving us key learnings. And today is a very special session. We just got done with our IoT day, and it was a grand success. We had 24 speakers in 24 hours. We had a live panel, and it was such a great success. And I would like to share about IoT Day for the first couple of minutes. I will quickly share my screen. Let me know if you're able to see. Are you able to see the picture?
Yes.
Here we are. So it was 24 in 24 AI. The theme of this IoT day was responsible AI research. How we do research, what are the broad topics that are there trending now, and what is life of a researcher. So we had amazing speakers with us, and we had a great lineup where we had the live panel too. So here is the montage that you can see. I would like to quickly go over the montage, and so this is organized by Sudha and Roxy Stimson, and me and Paria, we were there in the background doing the logistics and all of that, and I was also speaking. So it was amazing to have IoT Day being this successful this time, and we had Sam Wigglesworth, who has been teaching us NLP at Business School of AI. We had Sneha Mahakalkar, we have Marina Lau, Tejumade Afonja, Ashi Garg, Manpreet Budraj, Marty Liang, Mananden Duen, and we had Orewagine Ahia Nigeria, Divya Dwivedi, Ayesha Gautam, Aishatu Guadabe, Lisa Abieta, Usha Jagannathan, Aditola Aditungji, Susanna Raj, Malka Halgamuge, Pamela Gupta, Sneha Jadhav, Carolina Guzman, Dr. Chitra Dorai, Deepa Singh, Monica Manalova, and Ruth Nota. So we have Ruth here who has joined us for Weekly Wed today. And I heard Ruth talk during IO today, and we're so happy to have Ruth in Weekly Wed. And we had all these amazing speakers. So, Sudha, would you like to tell a word or two about how you felt about IO today?
This is the fourth year I'm organizing with Roxy Simpson. It is like a volunteer project outside of everything else we do. So it's something where it's called IoT Day Women. IoT is a bigger thing that happens on April 9th. and it's not something that we came up with, but we contribute by organizing a day-long session. So around the globe is 24 hours. So this time we thought we will bring 24 women, and we went outside of our network. My thinking is I did not want to just call my fellow speakers or students and just get 24 people. Wanted to find new talent, amazing people who are doing amazing things in their world. So these women you're seeing on the screen came from several different countries. And what we did is we did recording of their sessions. So for example, Ruth Nuduta did a session and showed us a collab about BERT. And Sam Wigglesworth from UK taught us NLP. And what we did was we got those as recording, and we showed them at 9 a.m. at their time zone, so that everybody could benefit around the clock. And then our time now, like where we are in Silicon Valley, we had like a 5-hour session with a lot of panel discussion. And I believe Yash was doing one of the sessions, so you're going to hear from her. So I think I have to go back and watch some of those recordings because it was too much after a point, So I missed out on some of the sessions when I, managed to sleep. So I'm hoping that we will hear back from some of the speakers in the coming weeks and have a longer discussion and learning. And some of them will be able to, we won't be able to do that time zone wise. For example, Malka Halgamuge is a professor from Melbourne, and we kicked off with her blockchain session, and we won't be able to bring her at this time because it's late for Australian time, but we'll be able to bring the recorded session for you if you're already part of this Weekly Wednesday, or signed up already for IoT Day. We'll make sure that we bring it to you. So back to you, Yash.
Thank you, Sudha. Thank you for that. And yes, so talking about IoT Day, it was really inspiring for me to see women from all corners of the world to come together and give us this learning. And as I said, the focus was on the research aspect, the responsible AI research, and all of that. We had topics from diverse background. It was not just confined to AI. It was basically the emerging technologies that have been coming out. As Sudha just mentioned, from Malka Halgamuge, we had blockchain. That's how we started. And there were a plethora of topics that were out there. So what you can do is you can go to Business School of AI/P/IoT Day camps. We had the schedule there, and we have the curriculum and all of that. And in the curriculum, you can see the sessions that these amazing speakers have given us. And there's an option to sign up. You can sign up and get the recordings too. So go over to businessschoolofai.com/p/IoT Day camps. I'll put it in the chat also. And
Yeah, I
it
just
will
added
be
the URL link for the recordings, where the recordings sit. Yeah.
okay, nice. And today I will be doing an extended version of the session that I did that day. I wanted it to reach everyone once again with all the other points that I would like to tell today. So let's go over and see the two research papers that I have been part of so far. And these two research papers, I would like to just a second.
So what is your topic called, Yash?
Just a second. Yes. So my topic is how we do research in responsible AI, focusing on data sets, the importance of data sets, the need for data sets, and what are the data sets that are available in responsible AI, and how do we bring in that and conduct research around it, set up experiments, and all of that. So
And is
here
it
I
okay if
go.
people ask questions, or should they chat questions? What do you prefer?
They can chat questions, or I think they can even voice their questions. That will be really good.
Okay. Thank you.
Yes, yes. So I will quickly go over that. So hi Dan, hi Ruth, hi Miguel, hi Aida. Welcome everyone, and let's start off with the research section. I'll just share my screen, just a second. So I hope everybody is able to see the screen. And the title. So generally when we write a research paper, so first we have the title. We tell what the research paper is all about in just a few words, which tells the main crux around which the research paper is there. So basically, the other day also I was telling that research paper writing is like a fruit. There is a seed in the middle and there is a lot of pulp outside. So basically, our work will be like a seed, which is concentrated and which is to the point, which we will be telling it in the paper. And around it, we will be telling the story, the context, what others have done in this. So when we talk about research, research is not just one man's deed where we sit in one corner and we do a lot of collaboration. We look at what others have done, how they have done, what are the best practices they have done, what are the advantages of the methods that they have used. Is there any loophole? Is there any point for improvement? And how can we bring in our expertise and make an improvement? So, first of all, for all of you here, you would be wondering why should we even do a research paper? Why should we even write a research paper? So first of all, we will be doing the experiments. Any research for that matter, we will be doing the experiments. We will have some conclusions and results. For the world to know, for the outside world to know, we need to write research papers and contribute to conferences and journals. So other academic researchers, industry practitioners, and independent researchers, they look at these, and they build on it. They can even challenge what we have done, and they can improve it if they feel there are points for improvement, and they can use it for their research and do something completely new. So this is like an interconnection, like how we have the internet. There is a research network that is there through these conferences, through these journals. So, as I said, our experiment design, our experiments, everything is just like the seed. We have the entire pulp around it. And so I started off with the title. I started off with the title. The title is really important because people decide to read or to go through based on the title and the abstract. So the title is the seed. The title tells what is it that we have done. And when we talk about the abstract is a concise version of our paper telling what is it that the outside pulp, or what is it about the story, and what are we trying to do, and how does this impact the world that is there outside. Writing an abstract is crucial to the outside world who are reading it, because in most of the journals and publications or conferences, just the abstract is seen and it's given for a preview, whereas the paper by itself needs a certain access, membership. It depends on the price of the publication and all of that. But the abstract is something that's given out, and people decide whether they want a paper, whether they want to go through it or not, depending on the abstract. So I can say that title is like the punchline, and abstract is the shorter version of your paper that you give, so that people decide to know to read or not to read. That's how they generally decide. And then, as I said, we have the introduction. Introduction is, as I said, the pulp, the stuff outside, and we say what others are doing in this area, how this area has got developed, and we tell the nuances of the topic that we are trying to cover. So then in this paper, so this is related to autonomous vehicles. We are trying to tell about inclusive ethical AI in human computer interaction in autonomous vehicles. So here the introduction we have told about AI, AV, and how AI is related to AV. What are the various softwares that are there which uses AI in the cars, in the autonomous vehicles? We talk about the ADAS, we talk about the DMS, and we talk about the SAE, the different levels of autonomy. Here is, we put a picture which tells about the different levels of autonomy. And then we talk about how the current role of humans is in the car, because that is what the research is about. And then we move on to what is AI ethics and inclusive AI. So we built a story. We started from AV, moved to AI, moved to AI ethics. And we are building on it. And once we move to AI ethics, we move to inclusive AI. So we are building the story here. And uh, now we say, what is inclusive AI? How is AI ethics and inclusive AI related to autonomous vehicles? And then we go over to the data set. So this is where I want to focus today. So first of all, when we talk about the data set here, we are trying to set up the experiment. We are doing the experiment design. We are trying to set up the experiment, and we pick a data set that others have created, or we create our own data set. So it is not necessary that we have to use what somebody else has created. We can create our own data set and use our data set for the experiments. Here what we have done, we have used a data set called Fairface. I would like to tell more about Fairface data set. Just a second. So Fairface data set, if you see here, it is a face data set. It has faces from people all over the world. There is a representation of people from different backgrounds, gender, and races. By doing this, they are trying to have a balanced data set. They are trying to have a good sampling approach where they consider everyone. So when I talk about responsible AI, inclusive AI, it is about bringing in everyone, creating AI systems that is fair to all, which is devoid of any human biases, societal biases, cultural biases that we already have. And here we have a data set which is trying to balance it out. And we take the Fairface data set and we look how there is a good distribution of it. And here we have set up some experiments about face detection. So face recognition, face detection is a well-researched problem from the ethics point of view. So we have Joy Bolamini, who brought about the algorithmic justice league, and she was telling about how when she wore a mask, the face recognition system could recognize her, and when she removed the mask, it could not recognize her. There it started off, and she has a lot of publications, and there is Algorithmic Justice League. You can have a look over that. And here in this paper, we are trying to see if there is a face, that is the a driver behind the wheel, where the autonomy is with the car. If the car has to see a person's face and detect it, will it be able to detect it? So, generally, when we talk about autonomous vehicles, we talk about people who are on the road and people who are inside the car. So, when we talk about people who are on the road, the autonomous vehicle should be able to identify them. And when we talk about people inside the car, the autonomous vehicle should be able to give them control or not give them control. So that is where we come up with this confidence threshold, wherein we say if we set the confidence threshold to 90, 80, 70, 60, how much percentage of people is the face detection software able to recognize and tell it's a human face, it's an alert face, we can give the control to them. This is very crucial. The first step before alert detection, we have face detection, and the first step to detect it's a human face itself, if you see at 90%, you see a difference in white and black. There is 36% white and 22% black. So on and so forth, we see the different races. But as we keep increasing the confidence level, so that is the threshold, we keep decreasing the threshold, and hence the number of faces that are detected is increased. And we see there is a difference. It's not equal all the time. And that is what we are trying to highlight here. And we have how it's faring for different genders, different races. So here I told about the importance of data set. When we are talking about ethics, when we are talking about fairness, when we are talking about bias, we can take data sets that are out there, statistically show what is the difference that is there, and how we can mitigate them. So we call it the bias mitigation techniques. So here what we are trying to do is this is the alert construct that we have extended the data set, and we have created called the AV face data set. So here you see somebody is crying, yawning, sneezing. So when we tell alert, is the detection system able to identify when somebody is crying, yawning, sneezing? And here we have taken from different races, different genders, people with different types of headgears and different types of clothing, doing different actions. So here we are trying to tell about the alertness itself and trying to tell we need to have a bigger construct, more diverse construct, and consider even people who are crying, yawning, sneezing. They may be crying or yawning or sneezing. They can get the control because it's in just that moment, but they're awake. Here we are trying to see if they're awake and if they can get the control. So this paper, the reason why I'm telling about this paper is twofold. So first of all, I wanted to tell how we write a research paper, how do we do research, why do we do it and tell it to the outside world. Secondly, what is the role of data sets? How important is data sets using which we can quantitatively talk about fairness, bias, ethics? How do we quantitatively tell? There are a lot of metrics. How do we come up with our own metrics? There is a whole area where we can come up with our own metrics for newer areas, for different paradigms of fairness. And here, so if you see this, there is there's a face of a man, a homeless man, and when the recognition system, detection system was given this, it recognized as a dog lying on its back. So it is not considering the economically weaker section in the training data set. So when we highlight like this, so when we highlight like this with data, with numbers, it has a larger impact. And so we come to the final section of the paper, which is the call for collaboration, where we try to call researchers from all over the world to build on the work that we are doing, to get in touch with us, and to collaborate on further research work. And yeah, the conclusion is, what is our experiment actually telling? What is it that we are trying to tell with this paper? What is the impact we are trying to having? So that is the conclusion in which we say. So, and then we have the references where, as I said, we build on others' work and others build on our work. We need to quote everybody from where we have taken what we have. So basically, a citation is giving credit. We tell from where we have taken, when was it taken, what is the location if we have to access it again. So this is one paper that is there, and before I move on to the other paper and about the other data set and all of that, I would like to take questions. So I'll quickly stop sharing my screen. And yes. So anybody has any questions?
Can you tell us what data set you started with? I mean, how did you decide on what the experiments you wanted to do? You just wanted to make sure that the AI inside the autonomous vehicle is inclusive. That seems like a simple English statement. Now, how do you translate that to the paper? And Susanna Raj is also asking, what criteria did you use to create your own data set? Mine was, what data set, public data set did you use, and how do you decide on the experiment? She wants to know how you created extra new data to augment that.
So we used a Fairface data set. So generally there is different types of data set like UTK face data set. These are all face data sets which have faces. And we took Fairface data set initially. And when we saw Fairface data set, the balanced technique that they have, and they have balancing of gender, race, and all of that. I would like to show a comparison of the different data sets that are here. So here, if you're able to see, you're able to see the Fairface data set, the UTK face data set, and we have the LFAW plus data set, the CELF-A data set. We can see that this is more balanced than this, and we can see how it is progressing. So basically, research is where one person builds on the other. So this is a team, and they build on others' work. Somebody started off with CELF-A and they've improved with LFWA plus. That's improved by UTK face data set, and Fairface has improved over that and providing a balanced data set over gender, race, age. So here we can see the age, gender, and race, how we are doing a better version at it. And yeah, Susanna's question, what criteria did you use to create your own data set? So basically, Susanna, it is what you taught us, the construct, the idea of a construct. Here we took the alertness construct. And we saw that how people are trying to check for alertness. They are trying to see if the eyes are open or eyes are closed. And based on eyes open and eyes closed, they are trying to tell whether it's, just a second. Sorry.
So while Yash is just coming back, I just wanted to add one thing. So there is a whole field called driver management systems, where car companies are putting a camera in the vehicle, and it could be regular camera right now. And then they're also experimenting to add IR camera, so you won't even know there's a camera watching us. which is a whole different field of ethics. But we found that they looked at camera data, which is same as facial recognition data, to identify whether a person is alert. And then different car companies would decide whether they would, if it's an autonomous vehicle, they would not give control to the human in case of an emergency. If it's a regular vehicle, they might say pull over or blink or give some kind of alert. But it's called driver alertness system, part of the bigger driver management ADAS module inside the vehicle. So back to you, Yash. No, we can't hear you.
Yeah, can you hear me
Yes,
now?
we can hear you. Thank you.
Okay. Yeah, I was telling about the construct, and we see it as eye open and eye closed. And then we wanted to show that although in crying, we are closing our eyes, that does not mean we are alert. And when we are sneezing, yawning, our eyes are closed, but we are still alert. We can still take the control and save someone's life on the road. So this is where the human, the autonomous vehicle gives the control to the human. That is the area that we have tried to address in this research paper.
So we added yawning, sneezing, and crying as 3 more definition of construct of what is alertness. Right? And we could have added more. It's just that for our purpose of our research, we just picked those 3.
So that was about the first paper. And any more questions that are there? Ada, Ruth, Dan, Susanna, if you have any questions, I can address them or I can go to the next paper.
There's a question from Ruth. Yes, Ruth, you can just unmute and ask questions. That's fine.
Yes.
Okay, I thought we were live, so I wanted to inquire: do you have to defend your results in the paper, or is that done afterwards? Let's say seek to validate the performance of whether the sneezing or covering your face affected how it performed against the original model.
Yes, we have the when we do the AV face data set and then we run the models and we check that it is more inclusive. We show that there is an improvement in the performance, and we show that also in the paper. And we have a baseline. We improve the construct. We get an improvement in the performance model, and we show it. Yes, we have to defend it in the paper.
How about validating your accuracy, like the improvement? Do you need to validate it?
So Sudha was telling something.
Yeah, I wanted to jump in, Ruth. Yash said that we have to prove that. So when you submit a paper, you're actually showing the results. You're not showing the code by which you actually ran it. So if you actually say that, yes, my performance improved by 5%, then you just show your graphs and numbers. And then when we submit this paper for publishing, it goes for peer review. So if we make a claim that doesn't statistically make sense, then the peer reviewers can come back and they can ask questions. And we have to answer every question satisfactorily, only then the paper gets accepted. So we have people like you who are already in the industry, who are in the editorial board of every possible journal. And so we are reviewed by peers. And if it is not satisfactory, they are not going to let the paper pass. Essentially, that's the check and balance. But yes, we do. If you're thinking of, are you asking about validating from a ML perspective, whether we are running the model and validating the model? Yeah. So we do set aside 10% and we run the model and then we test it ourselves. And then we will do, that's how we do that. Like typically you'll build a model and then you'll test whether the model is performing. That's what we did.
Okay. Any more questions?
So I was curious about where the problem of non-inclusivity is coming in the first place. So we know that, for example, the problems of biases in criminal court justice system, when you apply machine learning to predicting criminality, for example, there's a bias towards over predicting the criminality of African Americans, for example. And the problem that they identified in that domain is that because it's very hard to get data that is the truth itself rather than an approximation of the truth. So, for example, if you want to create a machine learning algorithm based on predicting criminality, and your data points for the committing of crime is a sentence handed down by a judge or a jury, those are riddled with a lot of human biases as well. So that is more of an approximation of the truth rather than the truth itself, right? Because nobody really knows the truth itself, like except for like God or nature. But the data that we're getting from is not the truth itself, but just approximations of the truth from judges, juries, and police officer arrests. So we can understand why a machine learning that is based on predicting criminality would be non-inclusive or biased in that sense. But here, I'm a little bit curious as to where the problem comes from, because the camera is actually capturing the actual faces of people, right? So where is the non-inclusivity coming from? Is it simply because there's too few data points coming from the underrepresented minorities and too many data points coming from white Caucasian faces, or is it coming from a different source?
So Sudha has raised her hand. Sudha, you want to tell something about this?
Yes, thank you. Thank you, Yash. Dan, you raise a good point that when AI is biased, the starting point of looking at it is the training data. So and then it creates a feedback loop. In your example of the criminal justice system, the data that was used to train the AI is biased because it is using historic data and it is creating a feedback loop and then unfairly pointing at African Americans in US as prone to more crime, right? So what is called recidivism. So when anybody is trying to look at inclusiveness in AI, the training today in the field is to assume the data is biased by which the training happened, and then figure out, how to get that by improving that by adding more data to it. So in a sense, we are just throwing more data at the problem, thinking that it will fix the bias. What Susanna Raj taught us was with inclusive AI is to go back to the foundation. And if people who were defining what the AI should be doing, if they were defining it with a more inclusive construct, then they would have collected more data. So what Yash showed, and if you don't mind me answering this, Yash, is that okay? Yes, thank you. So what Yash said showed us early on with the existing data set for faces. So the camera is pointing at faces in the vehicle. It is already using an API built by Amazon or Microsoft or one of the other companies, which is biased. In fact, the facial recognition APIs, the top ones in US, are banned by the US government because they are biased against more than 50% of our population. And so that is the first step. To your point, what they do in the criminal justice system, that's what Yash had shown, that we'll just run it with existing APIs and show that it's biased. But what can we do about it? Because there are existing APIs that used a certain data set and we have no control over it. So the approach that Yash took was to say, okay, what if we define the construct of what is alertness? And alertness was defined as eyes open or closed. And assuming that people are going to be alert and driving, and if they're drowsy, their eyes will be closed. Instead, there could be normal human behavior of sneezing, crying, and she had one more, right? 3 different categories where there could be different ways the eyes will show as if it is closed, but it's really not a person who is not alert. So that is how she changed the construct and then added more data for to prove that data set, and then tested out, okay, does that stand with the same set of APIs who are looking for facial recognition? Do they recognize a person's face as, first of all, it's a face that a human exists, and second, whether they show that the eyes are open or not when the person is sneezing. And there could be different, again, within the data set itself, we try to have at least, as unbiased data set with all kinds of races and faces and all kinds of lights and settings and stuff like that. Hope that answers your question, Dan.
Okay, thank you so much. That's very helpful.
Thank you. Back to you, Yash. And one of the things we are doing is in our papers, we are, once you start a paper, you tend to find more ways by which you can improve it. So it automatically leads you to more papers. So back to you, Yash.
Okay. And can I move to the next paper? The
Yes.
other paper that is
Yes.
there? Okay.
Susanna has made a comment here, very good point. She says non-inclusivity came from not defining alertness from a global perspective. A Chinese person looking sleepy because the training data was trained on Caucasian, whose eyelids were more open than Asians. So you redefine alertness. This is more inclusive and not just open or closed eyes.
Yeah, I was just answering the question Dan asked.
Yes, I saw that. I wanted people to hear that. That's why I read it out. Thank you.
Susanna, is there something that you would like to add apart from what you wrote there?
No, I think Sudha also covered it. It basically in the same way that the criminal data was, focusing on African Americans because it was trained on historical available data, that whatever data was available was already the over criminalization of a certain group. So when the training data was trained on that, it was biased. In the same way, alertness is now described as how open your eyes are and how big your eyes are. And some of us are born with very big eyelids and eyes, and some of us have very narrow eyelids and frame of in our eye socket. And that data was not trained on that. So once it was when you only define alertness as open or closed eyes, or how wide your eyelids are open, it was discriminating against a certain group who were naturally born with smaller eyelids. And that is where the non-inclusivity came from. So then you have to go back and redefine alertness as something more than just an open or closed eyes. And that is what you did in your paper. And that's what I was answering. Thank you.
Thank you, Susanna. I will move to the other paper, and that is also related to the construct itself. And we will take the conversation ahead.
Do you have time to show us another paper, the second one that you built on this one?
Yes. I'm quickly doing that.
Thank you.
So I want to go over the research aspect or the paper writing aspect here. We would like to directly get to the seed, the meat of the paper, and that is, so I'll just tell the title so that you get the context of what we are trying to do. So it is introducing inclusive construct label-centric approach for model performance enhancement into autonomous vehicles. So to give a little context, we know a model-centric approach and data-centric approach. Where in the model-centric approach, we'll be doing the hyperparameter tuning and we'll be getting the performance improved. And in the data-centric approach, we will be trying to uh, make the data representation. In context, we know yes. Did somebody want to tell something?
Sorry, Yash, my bad. I clicked on the live stream and it started showing your voice again. I'll mute. Sorry, I'm back here.
Oh, okay. That's okay. So, yeah. And yeah, I was telling about the model-centric approach and the data-centric approach. So here we are trying to introduce a new paradigm called label-centric approach. And the reason why we are bringing it is to have an inclusive construct. So that is this is something that's done newly by us. So we are using the word introducing that approach. And here, if you see this data set about in the driver management system where a person is trying to use the phone for texting. And so we use the data set from DMS. Basically, they have taken inputs, they have taken camera shots from people sitting inside a car, from people sitting in a simulated environment like this, doing various actions. So here we have different actions. Just 1 second. So here we have different actions that are there, and we can see that we can see the different actions that are there. And when we have a driver management system, we are trying to look for the movement and no movement here. What do we define as movement and no movement? So we got the data set from DMS data set, and we have extended the data set here again. And so first what we do, we did a baseline with the data set and we got a model performance. So we used CNN and we got it. And we got a model performance here. And then we did the experiment phase 2 where we added the phases, they extended the data set. And at the end, we extended the data set and the construct itself was expanded. So we had that and we had the results for the phase 2, which is here. We saw a model performance improvement here, if we see here. And we told that having a label-centric approach where we are improving the labels, the construct of the movement, no movement itself. So basically here we are trying to label the images in a different way, in a more expanded way than what is there earlier. So that is how we bring in inclusive construct. So that is what this paper is about. It's a new paradigm altogether. And we are open to questions now. So any questions? Dan, Ruth, Susanna?
Can you tell us about your data set? Because in this case, you are expanding the construct. In the last paper, you were expanding the construct of what is alertness. And in this case, you're expanding the construct of what is movement as it relates to alertness inside the vehicle. Can you tell us about the data set?
Yes, I will quickly share my screen. So I would like to show about the data set. And so this is by Weeklywed. It's the driver monitoring data set that they have. They have around 37 participants. So this is very important, the number of participants, because each participant, they will come with a different phase and the kind of actions that they make. And even the whether it's a balanced data set or not, if we see, we will get to know how many are male drivers, how many are female drivers. And here I would like to show the activities that are there. We have the distraction related activities, we have the gaze related activities, and we have considered these two, the distraction related and the gaze related activities. We have the VCD format that we have, wherein we can annotate. So we initially got an annotation from DMD, Vicomtech, and that we expanded for the phase 1 and the phase 2 of the experiments. So we used VCD format, what they have given, we used the tool that they have given. And so this is how the different data set that they have created. They have the in-car, they have the simulator, and they have infrared, the depth. We have considered the RGB for this. And this is how they have done the recordings. They have a camera in front. They have a camera at the side which captures the side movements. And they have, this is the side camera. And this is over here which captures this area of it. So we have here the hands are focused. Here the body is focused and here the face is focused. There are two scenarios. One is the simulation and one is the in-car itself. So they have been using this DMD data set for many things. You can go over their website and you can see it. It's a very good data set. It has been done with a lot of effort, that they have time and effort that they have put in. And in fact, in their paper, they have their paper in which they have introduced the data set. So here you can see the citation. If you go over the data paper that they have their own model and they're trying to show how their data set is better. And they have these tools called Tatao, using that. This is the tool that we used over here in order to do these experiments and do a further annotation. And so here you go. If you go here, you'll be able to fill your details and you'll be able to instantly access it. So you need a Boxes account and you will get the data set. So this is about the data set that we have. And that is the base data set that we used. And on that, we had the AV phase data set that we created.
So is it the same data set you used for the last paper, or because this was movement, you used a different, you created more data to augment your?
So here for this data, for this paper, we have tried to bring in inclusivity of the data set itself. Like if you see the people who have been the drivers there, who have been part of the data set creation, what if somebody was wearing a headscarf? What if their hair was flying? Is that considered movement too? There are different characterizations of movement and the construct of movement itself. How do we take it? And we have expanded that. And the data set that we have created, it is also considering the different aspects of a person, like a headscarf, hair flying. And so that is how we have tried to bring in the inclusive construct. So Dan, Ruth, Susanna, do you have any questions? Sudha?
No, this is good. Where are these papers right now? Where are they published? Can you show us? Where can people get access to it?
Our papers?
Yeah.
Okay, so the first one is published in Journal of AI and Robotics, and the second one is in Lattice, which is both international publications that are there, double-blinded, peer-reviewed. So I think Sudha will be is the best person to tell our double-blinded, peer-reviewed journals. And Sudha, over to you to explain what is double-blinded, peer-reviewed, how important that is, how do we submit, and how do we get acceptance. There is something called acceptance rate. There is a lot of parameters. If you see the conferences, the index, they have acceptance rate index, and there are various metrics by which all of these are gauged. So over to Sudha to explain about double-blinded peer
Thank you.
reviewed.
So when we submit the paper, we actually don't give our names or affiliations. And so they don't know when they receive the paper, they don't know who that paper is from anywhere in the world. And so whoever is reviewing it is going to look at it purely for the content. And then obviously whether the hypothesis makes sense, whether we run the right experiments, whether it's statistically sound, and whether we are building on other people's work and all that stuff. And the second part of the double blind is there are peer reviewers who are reviewing it, and again that is also not known. So it's not like they publish these are the people who are peer reviewing it, and you can go see what papers they have used or what their bias is. That's also blind, so we won't know who those people are. So in rotation, I think the peer reviewers will get to see papers that they provide feedback for or ask questions about, and then it will come back to us again blind, saying, here is the set of questions from the editors or from the peer reviewers, and then you have to reply back, and then if you answer it satisfactorily, then it could get into the pool. And based on how rigorous this is, different journals would have different rating. So if they do it truly peer reviewed and decent quality of content is there in those journals, then they will be cited more by other people. So then they would get a higher rating for the journals. So you could start off, I think this Yash brought this machine learning conference that was happening in Bangalore. And we didn't know it was going to the Lattice publication. And so we thought, we are publishing to a conference. Sometimes you can just publish to a conference. So I used to just publish my past work to conferences. Some conferences, after you've presented, they would actually publish that as a conference proceeding, or they might call you to build out a full paper. And that's where you share your entire experiment and research in the format that Yash was telling you about. So there's a lot of possibilities. If you're new to research, obviously easiest thing is to submit to a conference where you get to present and then it gets published. That's a lazy option, I would say. So you're not publishing the full paper, but you still have to do the rigor of the hypothesis and your experiment and what you're sharing. So I used to, not publish in real papers because it seemed like too much work to write with the academic rigor. And even the language with which you write cannot be an opinion. So I'm a technology futurist. I have a lot of opinions and I have basis for my opinions. But when I present, if I just say, this is my opinion, and we are going to get to a a full autonomy by 2030, it's just my opinion. Or if I say, yes, the data is biased against African Americans, it is still my opinion. It could be real, but I need to cite my sources. And so they would come back and say, for anything that sounds like an opinion in the paper, they would come back and say, what is your source? And so I find that trains us to think about how we are presenting anything very logically, and to be very, very, very respectful of other people's work, and not just think that we thought about it. It's possible that I thought of something, that's my original thinking, but maybe that exists out in the world. That doesn't mean that I'm the first one who came up with this. And so if we go look at who else has published on this topic, that's the first thing we do. to actually go through this double-blind peer review successfully, the first step is to start with, okay, has anybody done a paper on this topic? And do we agree with their proposal or their approach? And then would we like to build upon it? Sometimes somebody could have built something that you disagree or you think is limited, and you can augment to that. So there's so many ways of approaching that. It all comes back to the double-blinded peer review. And I love that approach. Instead of, there are some journals where they're not peer-reviewed or they're not double. So we see who the editors are sometimes, or they might even ask us to just, submit with our names, but then they would have a much lower rating in the industry overall. Yeah. Back to you, Yash.
Yeah, thank you, Sudha. And this session, we tried to cover what is the importance of data sets. So that is the focus of this session. So generally, when we tell about ethics, we talk about fairness and bias. We would have heard about it. But how do you take a data set? So here, now the question is, why should you set up some experiments, get some data, set up some experiments, and show that there is bias and how you can bring in the fairness? Because each of us, we have come with our lived experience, our background, our interests, our exposure, our experiences that we have gone through in life, and we want to bring in that into research. The world needs to hear your story, your point of view, your voice. So we would like to emphasize on start something small and try to get a paper, get it reviewed by others, and get the feedback, try to develop it, publish it, try to send it over to some of the conferences, and see, even the peer reviewers, they will be giving feedback. So it's a whole process, but it all starts from that motivation that you want your voice to be heard all over the world. So when somebody publishes our research paper, it's out there in the world. Anybody can read it, anybody can challenge it, anybody can build on it, and people use it for their study and for their experimentation. So here we are trying to take a piece of us, a piece of our thoughts, a piece of our mind, putting it in the form of a paper, bundling it and putting it into the world. And over there, it's going to sit for eternity, and people are going to use that for the betterment of the society. So, here, what I would like to tell each of you is if you have not written a paper, then go ahead, try it. There's always a first time, and we are always here to support you. So that is the main intention of this session. So, any questions that you have? We would like to take your questions.
Maybe just a quick question. So from my understanding, the solutions you propose for labeling correctly, what is the definition of alertness, etc., does that apply only to supervised learning? What about unsupervised learning? Are there instances in which your solutions would help improve those systems as well?
Okay. So when we talk about unsupervised learning, we will not have a label, right?
Right. So that's precisely why I asked the question. I was just curious. Maybe there's something to.
Okay. I think Sudha is a better person to answer this question than I don't know the answer. So either I ask Sudha or I ask Susanna to help us with this answer.
Yeah, thank you, Yash. And I like the way we are approaching this and not pretending like we have all the answers. So we went through that saying, okay, we want our whole thinking was we want to make AI inclusive. And the first approach of making it with inclusive construct that is applicable for anything. So it could be supervised or unsupervised, because we are going to defining the construct and augmenting data to training data. The label-centric approach, at least the way we went about in that paper, was with machine learning and not with deep learning. So it was not for unsupervised learning.
Oh, okay. Thank you.
But the construct concept, I think we could apply on anything. That's the thinking. So we don't just look at data. Because typically when you build models today and try to improve the performance, the basic one is model-centric approach, which is hyperparameter tuning, and you can improve the models. And then the data-centric approach that Professor Andrew Nick proposes is to start from the data and improve the model. And what industry does is they will get to a place where the model performance is not good enough, and then they'll throw more data at the problem. And so we thought, again, I think this is credit to Susanna Raj, about how when you look at a scene as a human, you see a lot more in the scene. Whereas when you take the camera to look at a scene and you look at the image, we are labeling pieces of that data. And so there is a lot more information that's left behind in the data that is not been labeled. So the label-centric approach is to expand the labeling to get more insights from the data. So instead of saying, hey, the car is looking at suppose I'm talking about the data outside. It's easier to give you an example that way instead of inside the car. So if the car is looking at the road and you're collecting information, it is going to look at trees, it is going to look at bicycles crossing it, it is going to look at the pavement and the road lane and other vehicles. So all of that are labeled. But there could be ducks crossing the road. That happens here in Santa Clara. So I heard that Google had done that, and they had people cross the road and come, with random things that they did not expect in the typical scenario. And Tesla had done that in Australia. They actually had kangaroos cross the road, and they wanted the cars to see that. So that would be unsupervised learning, but you want the car to see these things. So you have to go put yourself in the situation. So you collect the training data more organically. So with supervised learning, we basically said, what if we label that extra data, but we cannot think of all the gaps? Instead, typically it is called the ML gap optimization, where you think of what data is missing and you add a feature or a column to include that in your data to be identified so that the model is trained using that extra features. Instead, we basically said, what if we go back to the construct and say movement? So the example that Yash was giving in the movement data set with the 37 people that the public data set that we picked up from, they were actually saying, okay, people get distracted when they're drinking water. So they had people drinking water as videos in the data set. So they had things like that. Or people talking on the cell phone is a very common one called distraction, right? So we basically said, what if it is not that? If it is, I'm wearing a headscarf or a scarf or a dupatta, as we say in Indian clothing, and what if it is flying in the car? So that would leave a whole bunch of people who would wear, scarves. It could be any kind of scarf. And if you start looking at all kinds of scarves flying, it's going to, and inclusively across all cultures, it's a whole data set that we could bring in. And so just by changing the definition of that construct of what is movement in the car, that is a distraction. We just expanded that. So thank you for that question, Dan. I appreciate that.
Okay.
Should we wrap up, guys? This is awesome because Yash started out saying she wants to teach us how to go about looking at a paper for people who are not comfortable doing paper, but you have the knowledge to submit papers and get published. And you just need to come into the fold, because typically the papers are done by people who are on an aspiring path to do PhDs or who are PhD researchers or academicians. But every one of us who is in the AI field has something to contribute from our perspective. So that was what we wanted to bring more people in. In fact, we want to work on more NLP research. So, maybe Bert or NLP. We hope, some of you here who have experience in that would work with us, because we want to think about more inclusive construct from an NLP perspective for languages. So Susanna has a comment. Do you want Susanna just speak up, or do you want us to read it?
No, I was just answering Dan's questions in the chat. He was asking about unlabeled data. So in unlabeled data, you watch for clusters and you watch how many clusters are being pulled out and whether the clusters are meaningful or not. And that is, that is where you as a human come in the process to debias the model. But in labeled data, you do it at the earlier stage. You control the meaningfulness earlier by making sure that the construct itself is inclusive.
Yep.
It's just answering between the unsupervised and supervised learning and how you can debias in both of them.
Thank you. Thank you, Susanna. So Yash, do you have more to tell us, or should we wrap up this session?
Yeah, I think we can wrap up for today, and we can have one more session. We can continue the conversation and all of that. As we have done, we have Weeklywed every Wednesday. So do join us. We bring in speakers from all over the world, and there will be something to question and something to learn, to explore. And we are always open to questions and discuss.
Thank you, Yash. Thank you, everybody. Yash, you got muted.
Yes, thank you everybody for joining. Weekly Wednesday happens every Wednesday at 9 a.m. Pacific time. So do join us every Wednesday. We would like to have all of you here, and bring your friends also. It happens live too. And one thing is we send out newsletter and we tell beforehand who is coming, what they're talking and all of that. So do join us next time. Thank you. Bye.
The newsletter link here in case people don't. And we will add this recording also. If somebody misses and you want to share with your friends, here's the newsletter. And we are very big on, not spamming people and being very respectful of privacy and stuff. So you don't need to sign up for the newsletter. You can just go read it if you want. But if you want to sign up, it'll send you a reminder, and you can, we follow GDPR. You can always unsubscribe. And so we hope we can get more diverse people from more countries, more perspective, and, learn from each other. And we're going to continue to invite our speakers from IoT Day who had only 20 minutes time for the sessions to come back in for a longer conversations on the topics that they were doing. Thank you. Thank you, Ruth. I'm so glad you were able to join us too. Thank you, Dan, for all your questions. And thank you, Susanna, for being here. Thanks.
Thank you, Ruth. Thank you, Sudha. Thank you, Dan. Thank you, everyone.
Thank you.
Let's meet